So hello everyone, welcome to another particular lecture series of our reagent chemistry course, and this is the class 8. So in our previous discussion we have completed the nucleophilic reducing agents in brief. So now today onwards we are starting about the electrophilic reducing reagent, and in case of electrophilic reducing agent, two reagents are very important in terms of exam point of view, that is a Dibal H and the BH3. So we will learn these two reagents today. Okay, so let us start with our discussion with Dibal H. So first of all, what is the full form of Dibal H? The full form of Dibal H is diisobutyl aluminium hydride, and the prefix has taken to form this particular Dibal H. And it is a structure something like this. So there is the aluminium is there, and was the one hydride, and two diisobutyl is attached here. And now, since it is an electrophilic in nature, that's why this particular reagent present in the dimeric form. So the electrophilicity of aluminum getting reduced. So let us understand some information regarding the Dibal H. So first, it is an organoaluminium hydride donor. It is an electrophilic in nature, that's already discussed. And the interesting thing is this particular Dibal H is air and moisture sensitive, and it is a pyrophoric in nature. That means it catches fire in presence of air. So actually, this is the reagent that actually used in a low temperature. The reaction carried out in a low temperature because of this particular pyrophoric nature. Okay, and it is a temperature dependent reagent. Like low temperature, it will show another selectivity, and a higher temperature, it will show another selectivity. And the associated solvent with this particular reaction is ether, THF, DCM, and toluene. And the workup can be done by using methanol and water. So what is the role of Dibal H in this particular reaction? So Dibal H basically generate aldehyde. Okay, so if you want to generate ester to aldehyde, or you can stop the reaction in aldehyde position, not in the alcohol position, then you can use Dibal H. So in low temperature, it will reduce ester to its corresponding aldehyde, not alcohol. So it is a aldehyde generator, you can see. Okay, but in the case of higher temperature, this ester is reduced to the alcohol. Now it is not stopping in the aldehyde part. And not only ester, actually it will reduce cyanide group to their corresponding aldehyde. Okay, so let us understand the mechanism of this particular reaction. First, we know that Al is the electrophilic in nature. That means this particular lone pair of this oxygen will donate to Al to generate this type of bond. And here you can find that it will now this hydride come in the closer proximity of this particular carbonyl carbon. And now since this particular OAL bond takes place, so that's why this particular center, there is a carbonyl carbon center, become much more electrophilic, which facilitated the hydride attack here. Okay, and it is a four-member transition state has been formed. If you check here, like 1, 2, 3, and 4. So there is a four-member transition state has been formed, and this is the intermediate that is generated. Now, interestingly, since we are actually doing this particular reaction in the low temperature, it is a minus 78 degrees centigrade. So what happened that this particular intermediate that actually formed is very much stable in 70 degree, and that's why the product has been stopped in the aldehyde part, and the further reduction is not observed since this product this is much more stable in nature. But in the higher temperature, what happened that this intermediate is not that much stable. That's why after generating the aldehyde, then it will further reduction takes place to generate its corresponding alcohol. Okay, in high temperature it will generate the corresponding alcohol. But since we are doing this particular reaction in a low temperature, so this particular intermediate, due to this intermediate stable, that's why it will stop in the aldehyde part. So we can say that Dibal H is a contractor of aldehyde. Like uh, in ester or cyanide group is there, it will directly reduce to aldehyde. Okay. So that's why in low temperature upon hydrolysis, that is we have discussed that methanol water hydrolysis, that aldehyde becomes the major product. Now let us talk about some kind of reaction. Like here you can see that cyanide group is there, and Dibal H is used in the minus 78 degrees centigrade. That cyanide is directly converted to their corresponding aldehyde. Similarly, if you see here, this particular group contains an ester as well as an alpha beta unsaturation. So Dibal H is actually as much selective that it will only reduce that ester but keeping the double bond intact. Okay, and here you can see the reaction condition, that is a room temperature reaction condition. That means it will not stop in the aldehyde, it will further reduction takes place to form the corresponding alcohol and the double bond getting intact. Similarly, Dibal H is used to reduce the lactone also, like it is a lactone, and the it will be also reduced to their corresponding aldehydes. And in room temperature of 0 degree centigrade, the both of the center getting reduced to alcohol. Okay, now Dibal H can actually react with the triple bond also. So Dibal H react with alkyne to generate cis alkene, and this is the very important reaction. Like sometime it will ask in the examination also. Like if you want to make a triple bond to cis alkyne, cis alkene, so how we will do it? So we can simply say that give the Dibal H, and the reason behind is this four-member transition state. And due to this four-member transition state, actually the cis form is predominant. Now let us talk about the BH3 or B2H6. It is also an electrophilic reducing agent, and it is selectively reduce acid group in presence of other functional group. So BH3 not only reduce the acid, it will also reduce amides also, cyanide also. So here you can see that this is the acid group in presence of BH3. It will reduce to their corresponding alcohol. Similarly, if you have aldehyde and ketone, then also BH3 getting is done the reduction to generate their corresponding alcohol. And interesting thing is amide also getting reduced in presence of BH3 to form this type of primary amine. Cyanide also reduced, or you can say that here the reductive amination takes place to form this type of thing. But in the case of double present in the double bond, then BH3 will show hydroboration, that is the anti-Markovnikov of addition to generate this type of compound. So this is some kind of exception you can say. But in the case of other functional group, it will generate their corresponding alcohol or show reductive amination. Now, let us talk about the mechanism. The mechanism is simple, like Dibal H. So, since the BH3 is electrophilic in nature, that means this lone pair of oxygen actually coordinate with this particular BH3, so that this particular and this in the presence of amide, actually this was much more felicitated to donate the lone pair, because that amide also donate its lone pair here to get their partially double bond type of thing here, and this particular bond become much more donatable since the negative charge is actually comes here, so it will donate to BSC to make the chelate. Okay, so it is a 2 is there. So now this particular hydride will actually attack here this carbonyl carbon center, and this particular double bond or goes back. Okay, and now what happened that this particular lone pair will again go here, and this particular group is removed from the mixture, removed from the compound to generate the reductive amination product. And what is the BH3 reactivity trend? BH3 reactivity trend is first, if your compound contains acid, then acid will reduce first. Then isolated with double bond is getting reduced, not reduced, actually hydroboration takes place. Then amide, and after that aldehyde, ketone, cyanide, epoxide, and ester getting reduced. So this is the priority order of BH3 reactivity trend. Okay, so let us understand with some kind of examples. Like here you can see that ester group is there and amide is there. Now we are say the priority order of BH3, that amide group is reduced more over esters. So that's why actually in this particular reaction amides are actually reduced to their corresponding amines, but ester group is actually intact. Similarly, this particular have the acid. So in presence of BH3, acid will reduce to their corresponding alcohol. Similarly, epoxide case, the loose SN1 mechanism has been observed. Similarly, with NaBH4 that I am discussed in the class 3. So the more hindered side actually getting hydrates. So this type of product has been generated. So with this, we have to end this particular lecture. So in this particular lecture, we have discussed about all kind of electrophilic reducing agent that is important for the examination purpose. So in next class, we are talking about bridge reduction. So thank you for listening.